Good morning, good afternoon, good evening, whenever you may be. Hey, guess what? It's another week of science here at ACE Academy, live from the Brenna Bunker, deep in the quarantine Southeast United States. It's ACE Academy, 7th grade science. I hope everyone's had a fantastic weekend. I know mine's been exciting, including just a little bit of action, adventure, and ending in what's going to end up being a tragedy for the local neighborhood. But it is what it is, and the world moves on. But hey, guess what? I hope you guys stayed safe from the weekend, and I hope your lives are running along about as well as they can be based on what's going on. So I hope everybody, again, is continuing to work along here in science, frankly, in school altogether. I know the governor got on the mic the other day on Friday and basically said no school the rest of the year. Some of you guys are probably like woohoo. Some of you guys are probably like woohoo. But no matter what, we still have a lot, some material to cover before we get done with new material for the year. Grading thing, I don't know if anybody's poked into that. I may actually do an entire video on that, depending on what the school puts out, how close we were going to follow what the state says for public schools. But anyway, so lots of interesting things going on, and we continue along with our Earth Systems unit. So today, ours says, I can explain why there is wind. And of course, like wind, well, of course there's wind. When you go outside, there's wind. But, guess what? There is a reason that we have wind when we go outside. So as we start off here, it says, why is there wind? Well, first we have to define what wind is. And before we do that, we have to go all the way back and remember what air is. So air, or the atmosphere, is a collection of gases that surround the planet. Remember that our atmosphere is primarily nitrogen and oxygen. What are those things? Those are elements. These two elements are roaming free in our air, in this free state. And again, when we say primarily nitrogen and oxygen, remember it's like 78% nitrogen, 21% oxygen, and the rest of them, is 1%. Divided up among a bunch of stuff, to the point where they literally call some things trace elements, because there's just barely a trace of them when they test it. So nitrogen and oxygen are the two things that we talk about pretty much that are our atmosphere. And then they are roaming free. They are not combined with anything else. They are themselves, just plain elements. But when you see these plain elements by themselves, they're not individual atoms, but if you look at the picture here, they are paired molecules. And so we have nitrogen and oxygen. So in this picture, we have 4 blue ones and 1 red one. And since nitrogen is 78% of our atmosphere and oxygen is 21%, guess what the blue ones are? Yes, they are the nitrogen. And the little red one here is the oxygen molecule. So remember, you got to remember when we talk about wind that air actually consists of matter, and matter in the end has mass. So air is made up of these molecules. Since molecules have mass, Newton's equation for force can apply to them. Remember, F equals ma. Remember, force equals mass times acceleration. You get these molecules moving around as a group, and they can generate a force that we can feel. So the definition of wind is a mass of air molecules driven with enough acceleration to produce a force that can be measured. Sounds kind of complicated, doesn't it? But again, wind is a mass of air molecules, a group of these things, driven with enough acceleration. Remember, F equals ma, gotta be accelerating. There's a force that can be measured. So remember, when you push the little thing that spins around that says, hey, the wind's blowing, or you push the tree over because it's moving, there has to be what involved? A force. In order to have a force, you have to have a mass and an acceleration. Just remember those things, mass and acceleration. So if these molecules got up the constant speed to stay there, guess what? They're not accelerating anymore. You wouldn't actually have wind. But that's just how we look at things. So, well, now that we know what wind is, how can we figure out how it's produced? The answer starts to get a little more involved. We know that molecules of gas are already moving. They're a gas. Of course they're moving. They're not packed tightly together like a liquid or a solid. They're actually floating around, running into each other like bumper cars banging off each other all the time, and then changing direction and bouncing off another molecule. This is how gas is all the time. But how does a group of these molecules suddenly decide to all wander from here to there with enough acceleration to produce a force? There are a couple things at play to make this happen. First, remember this fact. All large-scale wind is a result of air moving from an area of high pressure to an area of low pressure. So remember, when we talk about large scale, we're talking like going from this state to this state. And I don't mean from gas to liquid, I mean from North Carolina to South Carolina, North Carolina to Virginia. So, the state of the country at this point, not the state of the matter. So we, talking about a large mass of wind moving from place to place. And when we talk about wind at that scale, we're talking about air moving from high pressure to an area of low pressure. So if I just blow out and you feel the stuff that's blowing out of my mouth, where's the high pressure? Inside my lung. Where's the low pressure? Over where you are. So the high pressure forces it to go out, just like turning on when you mash a ketchup packet, you create pressure inside that little packet to the point where it bursts, and then the ketchup squirts out and goes from the area of high pressure to an area of low pressure outside the packet. So wind is like that. So when we talk about wind on a large scale, moving from high pressure to low pressure. And that covers, it's kind of a blanket statement that covers all, large scale wind events. But in reality, no one cause can be pointed to all occurrences of wind. There are combinations of things, but wind on a small scale can have a different cause. Remember back to 5th grade when you learned about convection cells. Convection cells were a heat source. We're dealing with weather. What's the heat source? Yes, the sun heats up a fluid. Remember when we talk about things moving around, molecules together, whether it's a liquid or a gas, we always call it a fluid. A fluid, the air, and the warmer fluid air becomes lighter due to its lower density. Remember, we heat things up, the density goes down because the molecules are further apart. Since it's lighter, it rises up. Gravity has less of an effect, it goes up. This is what makes hot air balloons fly. Well, there can't be a place where nothing exists, especially when there are bazillions of other molecules just bouncing around. These other molecules of gas rushed into space that the warm molecules just left. And this movement of air from colder areas to fill the void where the warmer molecules just rose away from produces our surface breezes on Earth. So the sun heats up various patches of land based on how dark they are. We look at an overhead view. I love how Google Maps always knows where I am. Well, it thinks it knows where I am. It was close. So we jump over the satellite view here. And so, I did say satellite view and I did click on you. Okay, here we go. So we're gonna slide out here a little bit further into the country. Now we're gonna ignore the fact that there's a little line right here that's like a shadow when the airplane flew over and took this picture. We're gonna kind of zoom in a little bit and we're gonna look at this and we're gonna go, all right, so I've got areas of darker, and I got areas that are light, and I got areas in, kind of medium in the middle. Darker, lighter in the middle, darker, really light, really, really light. So you can see the different color variations. I mean, light tan over here. It really doesn't matter what actually physically the color is, whether it's dark tan, dark green, light green. So darker areas like this area right here next to the Rocky River, darker areas absorb more energy from the sun. Remember why? If you go outside and you got a white car sitting there and a black car sitting there, you touch the white car, it's like, okay, it's warm. You touch the black car, it's like, ow, that's hot. Darker things absorb more energy from the sun and become warmer. So the sun heats up various patches of land based on how dark they are. The dark absorbs more energy. The more energy absorbed, the more the patch of ground heats up. The hotter it gets, the more it starts to transfer that energy in the form of heat to the air molecules that are in contact with it right up. Again, so you got the ground right here, and then you got air up here above it. But again, it's air. It's like boing, 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 boing. Molecules are continuously running into the ground. Every time one of these molecules comes down, runs into the ground, it's there for just a little bitty short piece of time, but it's enough that it goes, oh, that's a little bit more energy, and it goes off faster. Oh, that's a little bit more energy, and it goes off faster. That's how heat gets transferred from the ground into the air. So now, as you transfer that heat energy into the air from the ground where it's absorbed it from the sun, those air molecules heat up, they move more, they transfer that energy to other molecules by colliding with them. So they're like, oh, I got more energy. And then they run into somebody else and they go, oh, here's some of that energy I just got. Over a period of time, the mass of air over the warmer ground becomes heated and it rises. Cooler air moves in to fill the void. We feel that inrush of air as a surface breeze. So again, so you got a patch of ground, it's being heated up. That air rises, cooler air from someplace else moves in to take the air's place, because again, we can't have a void with nothing in it. Something has to be there, so cooler air moves around. So that's where we get our surface breezes on the Earth. These little bitty independent patches of rising and falling air, and warmer air and cooler air. And those things moving around because of their temperature differences cause our basic, small breezes that we feel on the ground. And that's why air, it blows from one direction for a little bit, and blows for another direction for a little bit, and it stops for a little bit, and you're like, nothing's blowing, and then suddenly it comes from a different direction, you get a little puff. That's just the different areas heating up and other things moving to, masses of air on a small scale, moving in the taken. So these little puffs of air that move the trees around gently and seemingly change direction quickly and aimlessly. So I mean, it's our normal day-to-day weather. So we go back to our large-scale movement of air that produces wind. Can you remember a day when the wind was pretty high and it seemed like it was all coming from one direction? On days like this, the wind is pretty constantly blowing. If you look up and see this cloud in the skies, they'll be floating along, moving with the wind that you feel. This sight tells you that the wind is blowing up where the clouds are just as much as you are feeling it down on the ground. When it is windy like this, you know that the cause of this type of wind is when those air molecules are moving from an area of high pressure to an area of low pressure. So again, jump over here. So we look at a weather map. If you guys ever watch the weather on TV, and the maps will have things on them that look like this. And you got an L here, and you got an H here, and you got an H here, and you got an L down here. Wherever you see those H's and L's, those are centers of high H and low L pressure. So when you have constant large masses of air moving, when you feel that wind and it's always coming from the west, always blowing towards the east, and the clouds, you look up, the clouds are moving from west to east in the same direction that you're feeling this constant day-long breeze, you're feeling the difference between a high pressure, the air rushing out of the high pressure system to the low pressure system. That's what that feels like, is that continuous, ongoing, seemingly relentless movement of air in one direction. Of course, those are always the days that you're trying to set up a tent or a canopy or something like that, and you're just killing yourself or trying to rake leaves or something, and it's just the wind just keeps continuously ruining your morning. So again, I talk about the pressure, the packet again, you squeeze it, you're increasing the pressure in the packet, you continue to squeeze it, and the ketchup moves to one end, bulging the packet, you increase the pressure some more, and the ketchup bursts out of the packet. This is like the wind on a large scale. The ketchup was under high pressure in the packet. It broke out, moved to an area of lower pressure outside the packet. Air molecules do the same thing. They feel pressure in one place caused by a high pressure air mass. They move away from that high pressure towards an area of low pressure. This is the cause of wind on large scale. So when you're feeling wind that is just constant day in, all day, it seems like the wind's been blowing from this direction to that direction. The clouds are moving that way and everything else. That's where you have that movement of air from high pressure to low pressure. Now, the funny thing is, we go back to our little convection cell here, and truly, when you talk about, just that little local breeze, because some air molecules warmed up over there and moved up, and then these air molecules are rushing over because there's a void there. Well, again, that kind of void is a low pressure area. It's a very small one. It might be 50 yards across, but it's an area of lower pressure because the things that were there have left, creating a low pressure. So then high pressure air from just, down this block goes, hey, wait a minute, there's a low pressure point right over there. We're going to go over there because they think, they want to go from high to low. They want to get to the things always seek what they call the lowest entropy, the system of lowest energy. That's not important to remember, but just, but in this case, that they always are looking for the low, the spot with the lowest pressure. Now, since that spot continuously changes because of the heating of the ground, and you got to remember there's clouds wandering by, and this blocks the sun for a second. So suddenly this spot that was warmed up, now it's not warming up as much. Put that spot over there where the cloud's not blocking the sun. Now it's over there warming up that spot. And so it's one of these continuously changing things that's what produces our little local breezes. So that's why, the wind is different on different days. On some days it blows constantly from one direction, and other days it's just kind of bebopping around, coming at you from all directions because you're just suffering from, general localized breezes based on, where the ground's heating up by the sun. So we go back to our I can statement for the day. It says I can explain why they're wind. Again, on a large scale, it's air, just in every case, it's air moving from high pressure to low pressure. Just that, some scales, it's, high pressure system and low pressure system, and the wind's blowing the same direction all day. And then on other small scales, it's, the sun heated up that patch over there. That air got warm, it moved up, and then air rushed in to fill that void of low pressure. And then we feel a little breeze. I hope this has been a decent day for you guys here. This was a fairly short lesson. Wind. Get into some clouds tomorrow, so I'll take you guys outside. We'll poke around, see what the clouds look like, and see what they kind of things talk about telling us. So I hope you guys have a great rest of your afternoon. We'll see you guys here again tomorrow, and have a great one.